format, and you choose percentage. Click, and then it is
Okay, so week 6 already, yeah? So that means week 9 you'll have a team competition there. So team leader, have you updated your project yet?
yes.
Yeah?
Yes.
Yeah? We should do that, right? You
Yeah.
collect everybody, you give pressure for everybody. What do you update? Each of the parts, yeah? You will get a bonus from me. So you'll be, you know, be a hard, yeah? Leader, you have to be hard, yeah? Everybody have to make progress, right? Every week. All hands in the deck. Otherwise you will fail this course. I'm a tough guy.
Big question about Dataset.
Yeah.
So I couldn't find like really recent Dataset. It's the yearly.
As long as the trustable source is fine.
So
Doesn't have to be recent one. Doesn't have to be recent one.
I found the 4 years.
Okay, that's fine. Okay, so good. Don't worry. Yeah, just play. You need to play around. Show me what you have to play. You don't play, you never learn this course. I know. But play minimum 1 hour play for whatever capital, whatever Excel, whatever Python. Have you guys played ChatGPT? Yeah, you guys fall behind. You were fired by ChatGPT very soon. Yeah, you will be fired. Yeah, you have to take advantage of ChatGPT. Have you tried that?
This
No?
can write the report is better than us.
Yeah.
Like if you put the
Some of you A1 have a lot of good points, but no reference. I suspect you copy some idea from ChatGPT, but you haven't caught it yet. Yeah, very soon you will be caught. Okay, so that's why I give you a second chance. Yeah, it is for those who submitted to I. You need to submit a reply to me today. Yeah. Okay, today let's go. What's the time? So we need to. Today is pretty easy. It's kind of two algorithms we are going to learn: logistics and SVM, support vector machine. So which algorithm we learned last week? First two algorithms. Chemical class 3 and linear regression. Okay, so let's have a quick review. Okay, so the chemical class 3 is only one unsupervised learning without much knowledge, much dataset, pure based on your distance function, right? Equivalence distance function. So the idea, you have a customer, right? And so you wonder them, what are our major customers? So this is called customer segmentation. The easy way is to group them together. So whether this is a young girl fashion buy our clothes, or the senior guy like me to buy, right? Then you design your business to fit this user segment. Of course, ideally you're doing personalization, yeah, but that takes more machine learning. But a very simple way to use that is clustering. So basically, this is your problem space, and you have a lot of data set, right? Yeah, you have 1,000 data set for your project, and you want to group some of them together. Yeah. So it can be 1, 2, 3, 4. Yeah. So what's the optimized group you should divide for your customer, right? And so this is called key. Yeah. So you use the function called elbow. So this is K, this is the WCSS. Basically, the idea, if you are, everybody wants one group, right? The distance between you is a lot, you add them together. Now you divide by two groups, right? This is the Indian group, this is the China group, this is a maybe Brazil group, three group, right? So you distance to you center is shorter, right? You don't come to China, fly to India for a meeting, right? You meeting with you, right? So this distance is getting shorter, yeah? Maybe you divide by 4 groups, even more shorter, right? But if you divide much more, the distance is getting bigger again. So that's a turning point. Which arrow point to, which is optimized, cluster, yeah? So you are using this one for cluster. Then you divide which group. Then for each of the group, you decide center, yeah? So you have center, any new group, new customer come in, you just measure his distance to 1, 2, 3, 4, which is shorter. Then you divide that group, right? Yeah? So this is a k-mean clustering. And I'll give you a Python demo, yeah? To do the iris flower cell, yeah? Now, it's much easier for you guys to learn Python because there's a ChatGPT. Yeah? You just tell ChatGPT, write a Python program on k-means, on iris flowers that can write code for you. Then you just run. So I think I strongly recommend, because it's AI technology, right? Everybody should learn Python. Right? For me, it takes 2 years. Now you can take a command. I will show you. Yeah, it's easy. Yeah, that can show you arrow graph and also give you outcome, right, to your project. Yeah. So that's the way you have to adapt to this technology, right? If you don't adapt, you will be out. Yeah, that's always like that. Yeah. Okay, so this is the k-mean we learned. So the second algorithm. Any question about the k-mean? Have you watched all the video, right? On your hotspot, right? You got an idea, right? It's mandatory. Who are going to do k-mean in your team? 1, 2, 3, 4. Okay. I recommend use ChatGPT, and I will give you a demo soon. Yeah, see whether it works. Yeah, then let UCW know. Yeah, but we do it Python. Python is fun. Okay, learn Python, but don't copy from your essay. Okay, so the second algorithm is a linear regression. Okay, this is essential. So linear regressions, suppose you have x and y. X is independent, y is dependent. Year of experience, how much pay, right? I give you Excel. Anybody try the Excel Dataset? Yeah, good. Good. You have not tried? Excel? Yeah. Use Excel? Yeah. Everybody, right? This is simple. It's basic skills. You don't try, you never learn. Believe me, you don't try, you never learn. You have to try it. So basically, you have data set. Your sketch diagram, right? Look like strong positive, right? Linear relationship. So in your brain, you like to fit this one linear line, yeah, and to fit it. Right? And the formula for linear line is y equal b0 plus b1 x. Okay? So this is intercept b0. This is slope alpha 10 is b1. Once you decide b0, b1, you always draw this line. Yeah? Linear line. Right? So we use least square method to determine, right, how to get b0, b1. Basically, each data point, then make error. So some of you overpaid, some of them underpaid, right? Yeah? Then you square. Then you try to minimize this put error. So you can able to get B0, B1. Okay, so you must try. You don't try, you never learn. Yeah? It's there. Everybody can try. And so this is a simple linear regression. But there's other factor determine your salary. Yeah? Besides of the year of experience. Your education. I have an MBA degree. Yeah, that'll give you more money. I'm a high IQ. I'm a quick learner. Give me more money. Yeah? I'm more beautiful. They have to pay you more. Yeah? So this is a X. It's a X1, X2, Xn. Yeah? So this is called multi-factor linear regression. So this way, you express this way to n and bi xi. You get it for multi-factor linear regression. And you can express matrix way. You can learn from matrix, right? From high school or university. You just simply say y equal xb. So the B kind of matrix. Right? Simple like that, yeah. So this is a linear regression and also multiple linear regression formula, okay? So this is very basic, very useful. So today, 2 algorithms based on this linear regression. Okay, so I give you an overview for now, then it's much easier to understand. So that's the beauty about the campus course, yeah? So your professor can be able to explain in a plain language. Then you will learn by yourself much easier. So the logistic regression, okay, so a lot of problem is kind of a classification problem, okay? You know, whether I have breast cancer or not. Yes or no, yeah? And at end of the year or mid of the year, your boss, think about whether you deserve a promotion or not. Yeah? Or you deserve a promotion? Yeah? You yes, you get salary increase. Yeah? It's kind of yes and no. When you drive a self-driving car, right, on the road, right? There's a shadow across the road. You identify that is dog, this is a bear, this is a human, right? It's a classification problem, yeah? This is a reality, yeah? And so, logistic regression, basically, they use this formula, convert linear regression to the E minus and XB, yeah? So this is a linear regression. Convert to there. Okay? So what's this one? If you plot this formula result, this is a famous S-curve. Okay? So the top is 1, this is 0. And the threshold is 0.5. So this is a probability, yeah? So I'm not sure. Let's do calculation about your performance, right? If you Y, the probability get promotion 0.75, that means yes, you deserve. If your performance factor, including your education, your experience, your achievement, the result is 0.35. No, you cannot deserve promotion. So this is basically convert this linear regression, same efficient coefficient, to logistic regression formula. Yeah? And this is called famous S-curve. S-curve is everywhere for machine learning, AI. Yeah? Try to figure out something based on the probability, right? you read it like S-curve, right? Yeah, S-curve, S-curve. And so this philosophy, right? If you work harder, you get more grade, better grade, yeah? And if you boil water, eventually you boil water, right? So this is a S-curve, and used for every machine learning, okay? So logistic regression, that is a concept, formula. So everyone knows what is E, right? What's the number of the E? Okay, remember? 2.78. Yeah? So basically you can convert for that. And so this is a logistic regression. Based on linear regression, use this formula, convert it. What do you just remember? S-curve and this formula. And the second algorithm we are going to learn is called support vector machine. This is also based on the linear regression. For example, this is your problem space, the dead points. You know, this kind of situation, you know, breast cancer. This kind of thing, you have no breast cancer. Do you have any family who have breast cancer or die from breast cancer in your class? Yeah, yeah. Who?
My mother-in-law.
Mother-in-law. Okay.
Yeah.
He still here? Survived?
Yeah, she's.
Okay, okay. So how is the diagnosis for breast cancer?
Well, the doctor removed their breast. So
Yeah, how the diagnosis of breast cancer?
She felt a lump in here, so she went to the doctor or.
Take some flu T-shirt.
Yeah.
Yeah. Then okay, so we will solve this kind of problem. Yeah. And so every lady doing this even there's suspicious, right? Take some X-ray or flu test, then you get that point, right? So then you decide who have breast cancer or not, right? So you will use the linear line to divide. So this is breast cancer, is no. You make a lot of mistake, yeah? And if your mom have no breast cancer, you diagnose, oh, you have breast cancer. You are scaring your mom tonight, yeah, until for second death, yeah? And if the worst thing is, if your mom had breast cancer, but you say no breast cancer, what happened after 2 months? Yeah, mom will die. Yeah, so this line division is critical for diagnosis, medical diagnosis, right? So what's support vector machine doing? They use 3 lines to divide. One is +1, one is -1. So this is called hyperspin to divide 2 data sets. Try to maximize this big spin to increase the accuracy for diagnosis, right? So this is called support vector machine. This is logistical regression. Okay? So both algorithms is widely used for machine learning. Particularly, I love this support vector machine. It's kind of mini neural network, yeah? And very practical to solve a lot of problems, yeah? So based on both from this linear line, yeah? Okay? So that's today we're going to learn. I will give you a demo on the breast cancer dataset. Use Python, also use Excel, yeah? If possible, I can show you the ChatGPT, yeah? You can do that for use Python. Okay, so let's quickly go through today's lecture, then help you to understand. So, the logistic regression support vector machine. So, you know that, right? AI is coming. So many AI can do prediction, yeah? And more importantly, called decision automation, right? Doing self-driving car, doing people-list retailer, all this, decision automation, right? This, so we more focus on the predict and decision interpretation, also called prescriptive analysis. Yeah. Not only decision, right? You have to. This is human. You have to stop yourself to try to kill this human. If you have a self-driving car, right? You have to take, act accordingly, right? Not only make a decision. You have to act on that. So in general, we learned 7 methods in this course, and we reviewed K-mean only once and supervised learning. We learned linear regression, and we're going to learn the 2 and 3 today. Then next week we learn 4 and 5. Then last week we learn time series forecasting, right? Total 7, including the K-mean. Most of the problem is called classification problem. That's why the 2 of you were focused on the classification problem. Yeah? Classification problem. So this is 7 algorithm, right? We are allowed to learn artificial neural network, right? So you can take the other course, and typical for ChatGPT, which is a neural network, yeah, very complex neural network, yeah, billions of learning points, and so natural language processing we are allowed to learn. So you guys just learn this method, apply for your dataset, and also your final exam dataset I give to you, right? So we will use this CRISP DM process, 6 steps, which you submit your team project proposal. What's problem you're going to solve? Yeah? Today we will solve the breast cancer problem. Yeah? And what's data available? Right? That's what you decide, which data available. Right? Minimum 1,000 row. How many column you have to tell me? Yeah? And then you need to prepare your data. Basically, you do some cleaning. Yeah, the data, some of the missing field, you need to fill up. Missing her age on your age field. You can use the average age, put her age, or based on her graduation from high school at her university. Then you figure out her age. Yeah, so you data set, it's a million data set, right? It's remarkable, right? You have only small data set, keep her, right? Because every person is key learning for you. Then you're doing visualization to take a look, right? Yeah, for this breast cancer, male, female. Male could have breast cancer too. Yeah, what's the age group? Yeah, so you need to do visualization. Yeah, and which geographic have breast cancer? Yeah. For Canadian woman, what's percentage of Canadian women in lifetime have breast cancer? Yeah, guess? Yeah, 1/4 Canadian woman. That's a lot. Yeah, and 13% of them will die from breast cancer. Right? This is significant, right? Yeah, number 1 killer for woman, Canadian woman here. So that's why we need to solve this problem. And then, do modeling, do different modeling, right? In order to training, yeah? So you train the model like GPT, right? ChatGPT. Now they're very smart, they can answer your question, right? So what we ideally, you train the model, you put a mobile phone, and your mom can, scan it to check, whether she has breast cancer, right? Yeah, the earlier time to diagnosis, right, the better, yeah? And that's a multiple model to solve the problem. So we discussed about 7 of them, and we will use 5 of them, use Python. Then you select which model, the best model, yeah? And so I will give you the brief, right? It's called confusion matrix, and also called accuracy. Which model have accuracy, right? So you get crazy about ChatGPT, right? You answer the question, the answer is better than you, right? Yeah? And everyone believes that is the right answer, yeah? More accuracy. And then you select the best model to deployment, to do, diagnosis. Okay, so this is total of 6 steps to do business analysis, data mining. As I mentioned, most of the problem is a classification problem. Yeah, that's the one you give exact number, the one that you yes or no. Yeah, A, B, C, D, classification problem. Same thing. So this way you train your model training, then after model training, you're doing model prediction. Yeah, use a model to predict. 2 main steps, like training your children. So logistic regression, also called logistic classifier. We talk about classification problem. Yeah, and classification mainly they learn from previous knowledge, then doing prediction. And so that we did Excel. It's last week for how much you deserve pay. Yeah, for last interview question. You must try this Excel, yeah, by yourself, basic. So, kind of review. We try to fit the data point with a linear line. So this is general formula for linear regression, yeah. So that means multiple factor x, right? x1, x2, x3, until whatever you want. Okay, we use this square, and which to minimize error, yeah, because each data point have an error point. You square it. It's called least square method. And so eventually, for the least error, so this is your you pay. Suppose you get this pay, you generate error, yeah? You minimize this total error. And so you can use the R square to measure the performance. Yeah, we use the residuals graph, right? For each data points, that error. Yeah, the error should be evenly laid out about your zero line and loop pattern. Yeah, looks good. Some of you, underpay, some of you overpay, and most of you should be all right. Yeah, so that's called residual from Excel. So logistic regression, as I mentioned, that is the formula for logistic regression. Okay. Is convert the linear line to classification problem based on the probability, yeah? And if probability more than 0.5, that means yes. If probability less than 0.5, that means no. Yeah? So you figure out probability. So this is famous, the S curve, right? The middle point 0.5, the top is 1. Because that logistic function, right? The maximum is 1, minimum is 0. Yeah, it's S curve. So there's a lot of application. For example, right? You want to make a movie, because but you need $5 million to make such a movie, right? And you need a producer to sponsor you, right? The question. The sponsor, investor asks